done by Wednesday. That's in the MRC for you. You just go up, just like your normal test or quiz or anything like that that you missed. You just say, hey, I'm blah, 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 here to take. You can just say a test, and they'll hand you the same thing. It's a green piece of paper, so if you have multiple pieces missing, and they hand you like a yellow piece of paper or a blue piece of paper or a white piece of paper, it's not that piece of paper. It is a green one, so make sure you get the green one. It does say extra credit on top, but you have until Wednesday. After that, I'm just going to go in my folder and recycle. Okay? And it doesn't hurt you. Even if you are not confident at all, go take it. It can only help you. It cannot hurt you. Go ahead and open your note packets to 11-2. We're going to be working on some operations today. And we're not skipping all of these. You are going to do 4 and 1. And I'm only going to give you 2 minutes to go. So when that hits 3 minutes, we're moving on. So try it out. 1 and 4.
I don't know how to do this. Hey, where are you guys screwing anything?
Right.
I'm good going to die.
Only like an hour. Hour and 5 in the bus.
Well, we have an hour and 45 minute drive. For you guys to nominate. And they are crappy too. I mean, it's fine. But the batting cages are awful. It was a bad day, but we still got it. Only the small ones came out. You should make sure.
Just show it.
I didn't think you was actually in this class.
I didn't think it was in this class.
I thought it was only you.
There's a couple other days.
Nicholas, can number 1 even be done?
Yes. Well, folks, that's the time. When I look at this one, a lot of people chose 9 times 6. It's a good option. You know the square root of one of those numbers? I hope so, right? 9. If you know the square root, we don't have to keep breaking it down into the product of its primes. I can just cross it off and go times 3 on the outside. So I'm going to get 12 times the square root of 6. And if we think about that, I didn't write anything about 6. Could I break 6 down? Yes. And I am breaking 6 down. I'm thinking about 6. And I'm like, okay, the numbers that work for 6 are 2 and 3. Not a pairing. And there's no other numbers in there. So I'm not going to break it down because it doesn't. Leaving us with their answer right here. Questions on that one?
Did you get the 33?
The 3 comes from the 9. So I'm taking the square root of 9, becomes 3 on the outside. All right. If I look at 4, I gotta shut these a little bit. I forgot there's glare. If we look at 4, we got our cube root. 16 I'm going to break down to 2 times 8. my x's, I'm going to write them in groups to match my key that's out there. So 3 matches the 3, but then that means I have one x left over. So I split that up. And then the y, I got y cubed times y cubed. And again, that represents the 6. 8. Is there anything special about 8? What's the cube root of 8? 2. I don't expect you to like know a lot of cube roots or stuff like that, but 8 is kind of a nice one. It shows up a lot. And if we start pointing these numbers out and we start recognizing them, I don't have to break that down anymore. I can now cross this 8 off, just like I crossed that 9 off, and I get to write 2 out in front. So I'm going to do that. I'm going to write 2 there. If I look at my x's, this cancels out and gives me 1 x on the outside, right? I had 3 x's, so they come out as 1 x. I look at my y's. This gives me 1 y on the outside. This also gives me a y on the outside. So I get to write that as y squared on the outside. And then I'm going to be left with everything that's still on the inside. So in this case, I just got a 2 and an x. Before we move past that, if there's any questions at all, please ask. Because if we can make sure we're good here, then today gets easier. Yeah.
Does it matter what order it is on the outside?
No. Typically, it's good practice to put your number first, and then the variables don't matter. If you have y and then x or whatever, it doesn't matter. I wouldn't take off points if you put x squared, or sorry, y squared first, and then put 2 times x or something like that. That's fine. It's all multiplied together. Other questions? All right. Today is all about adding, subtracting, and multiplying these things together. And we get to learn a few rules. And these rules actually kind of go based off your belly button. And you see what I mean by that in a little bit. So, a couple things though. You can either simplify or you can multiply together. It doesn't matter how you look at this. So I can look at this and say, you know, the square root of 4 is 2, square root of 9 is 3, multiply it together, I get 6. Nothing too crazy there. You could have did that right now. The other option is go, well, I can write this as 4 times 9. Notice we wrote this as 1 square root. That gives me the square root of 36, which we know the square root of is 6. I'm going to give you one other example, and this is where we talk about your belly buttons. So, again, we have 2 options here, and one option is not necessarily better than the other. Sometimes I'm going to choose to follow along something like this method. Sometimes I'm going to choose to do something like this, and sometimes I'm going to choose to do something like both of them. Okay? So we're just kind of see that as we go. But I want you to write this out. 2 square roots of 3 times 7 square roots of 5. So we look at the outies, which are right there, the 2 and the 7, and I just multiply them together. I get 14. Then I look at what's inside the radical, the innies in this case, the 3 and the 5, and I multiply them together and I get square root of 15. So that's how we multiply. It's just about your belly button. Innies go with innies, outies go with outies. The other thing about that is when I look at this, I always have to check, can I simplify this? And I actually know I can't because I know the numbers that I use to multiply. 3 and 5, there's no pairing there. It's done. So that'd be your answer. You ready for a couple problems? Some of you are like, heck no. But here we go. So we're going to do number 1. We're going to do number 3. Now, number 1, I'm going to do differently than I do 3, so you have options. When I look at 1, I'm going to start by just writing these 2 things under the same radical. And I'm going to try to reduce them. So I'm going to put a hold on 8. what two numbers can you multiply together to get 32? 2 and 16. Give me two other numbers. 8 and 4. Also an option. Now, I'm going to choose the 8 and 4. Why would I choose 8 and 4 over 2 and 16? Right. I only need a matching pair. And if I get 8 right here out of this, I have a lot less work. You can choose 2 and 16. It works. Right? We talked about that yesterday. You can choose any numbers. They will work as long as they multiply to make that number. But in this case, I can save myself some work. So the 8 stays. But when I go 8 times 4, well, I have a pairing right here. Because I have a pairing, those two 8s come up in front as just one 8. Now, I hope you're looking at this kind of funny. Do we know the square root of 4? Yeah, it's 2. So that actually means this goes away. And I'm left with 8 times 2, which is 16. Now, Wendell, I'm going to pick on you for a little bit. So, Wendell, hold your calculator up. If you have a calculator like Wendell's, that means that you could type that in at the start and it would spit out 16. It also means he could type in the square root of 40 and it will kick out 2 square roots of 10 without doing any work. So you might be thinking, well, why does he get the opportunity to use that calculator? Or why do some of the people sitting next to me get the opportunity to use that calculator? Because I don't care about the answer. If you give me the answer, I don't give you any points. I only give you points if I see the work. So we're testing you on your ability to show the work. All right? And because of that, I really don't care if you have that calculator, because it can only help you so much. It can give you something that doesn't give you any points. So just make sure you're focused here and we should be fine. Questions here? 3. So this is where I said I'm going to do it slightly different. The last problem, I didn't multiply them together. I just broke them down and then reduced them. Here, I actually am going to pretend to multiply them together because I'm going to multiply the first two things together. I'm going to multiply the outies together. We're going to get a 6 on the outside here, and I'm going to have a square root, and then I'm going to do what I did over there and just put 12 times 6. What do we want to break the 12 to? 6 and 2. Yeah. And 3 and 4 is normally the great option because 4 you can take the square root of. But 6 is a better option because I have a pairing. I have a matching set. Writing this out, I get 2 times 6, and then I have that other 6 that was already there. These two 6s are going to come out as 1 6. Leaving us with 6 times 6, square roots of 2, or you can actually jump right here, 36 square roots of 2. Questions? I want you to try number 4. I'm seeing good stuff as I walk around, so I'll just finish this off if you were kind of stuck. So I get 2 and 7 from the 14, and a lot of us had gotten there. And then I'm going to choose 7 and 5 for the 35. That gives me these two 7s that come out as 1 7. And then the 2 and the 5 is stuck in there, so I get 7 square roots of 10. And we're done. Now that's what it looks like with just numbers. But now we're going to add some variables. And the variables don't actually make it that much more difficult. When I look at 6 right here, we're skipping 5. I'm going to do the same exact thing I did in number 3. I'm going to take 2 times 3, and I'm going to put a 6 right there. Then for the x's, I'm going to do some rewriting. I'm going to actually multiply those together. Normally I don't, but in this case it's kind of helpful. I'm going to write that as x to the 4th because I had 3 and I have 1 right there. I'm not going to multiply my numbers together. Instead, I'm going to write it as just 2 times 6. Can anyone tell me what the square root of x to the 4th is? It is x squared. It is. Because remember, this is a 2 out here. And if I would rewrite that as an exponential power, this would be x to the 4th divided by 2, which is x squared. Now you could also group them. We could group this as x squared times x squared. And hey, look at that. We got a matching set. They come out as just x squared. So we're going to do that. We're going to have 6x squared. And inside here, I'm going to have 2 times, and I know you know 6 breaks down to 2 times 3. We get to take these 2's out. And do I add them to the 6 or do I multiply? We multiply. Always, always, always. So we end up with 12x squared square root of 3. Questions? When you're ready, you can flip the page up. All right. This is different now. We're no longer talking about belly buttons. We're talking about apples and oranges. So, your facial expressions are kind of fun. So, when I look at this, I want you to treat it almost like an x and a y. If you look at your square roots and they match up, you get to add them together. But 9 and 4 is not the same, so this would be like x plus y. So I'm not actually going to do anything. I know we could add them together because it's 3 plus 2, but we're not going to worry about that one. We're going to skip over here, and if I look at 5 and 5, that actually just becomes 2 square roots of 5. It's like if you would go x plus x and get 2x. It's the same idea. So when I look down at example 3, square root of 3 plus the square root of 7, if I gave you that on a test, put a circle around it and say, that's my answer. It's done. There's nothing else to do. Now there's a little trick that happens once in a while, and we're going to get to that with our examples. Example number 1. I look. It's almost like a game of Pictionary. They're a matching set. How many do I have? 7 square roots of 7. I add the numbers out in front, so I add the coefficients. If this was 3x plus 4x, and I asked you what the answer was, you would tell me it was 7x. Well, x is just the square root of 7. So this gives me 7 square roots of 7. When I look at 2, I look, do I have a matching set? And I do. I have the square root of 15x. So I have negative 9 plus 10 giving me 1. So my answer is really just 1 square root of 15x. We just combine the pieces on the outside. That's just telling you how many you have, and you just add them up. You do have to check though. Square root of 15, can I reduce that? Nope. It's all good. So we're done. 3. I match them up. Square root of 3, square root of 27. Do they match? Yes. They do match. Thank you for the question. Because the square root of 27 is not simplified. You have to make sure that you simplify before you do anything else. So the first thing I do is I will look. And the first thing I would do when I see 3 is go, they don't work. But then there's that little voice in the back of your head that's like, but they might. And you gotta listen to that little voice and you gotta check this out. Is this piece simplified? Can I reduce that anymore? No. So it's done. It's simplified. We're good. Is this piece? No, I already told you it wasn't. So we gotta reduce. So I'm gonna put 3 square root of, give me 2 numbers for 27. 3 and 9. 9 and 3. So I'll put 3 times 9. Oh, look at that. We know the square root of 9. Crossing that off, I put times 3 out here. I'll do that in another color. So I crossed off the 9, put that there, and I get 9 square roots of 3. Then we just drop that negative 2 square roots of 3 down. And we add them together. So how many square roots of 3 do I have? So we got 7 square roots of 3. Now, you will get a problem like this. It's a little bit deceptive, but it's really nothing too crazy. We're not going to give you something insanely hard to simplify, but we will give you something to simplify down, and then you got to check. Does it work? Does it not work? And if it works, combine them. If it doesn't work, then you're done. And it's in the most simplified form. Questions? Five. You reduce the first part, I'll reduce the middle part, and the last part's already reduced. So you reduce 2 square roots of 8. Put that in its simplified form. Two square roots of 8 is what? Is what? 4 square roots of 2. Now, when you see the square root of 8, we actually knight you as a math nerd. We let you join the math table. If you know that that's just 2 square roots of 2. All right? So watch yourself. If you start recognizing that and then go, hey, that's just times 2 because of this problem, that's a really quick answer, right? But if you start recognizing this, we knight you. Can't get rid of it. Nerd for life. So, taking a look here. First 2 items. Don't work. Can't combine them. Last 2 items. Don't work. Can't combine them. So I jump. I go first and last because they are the same, and I combine them. How many square roots of 2 do I have? Yeah, we got 11 square roots of 2. And then I got minus 10 square roots of 3, and that's it. Put a box around it. We're done. Don't try doing any magical things and combine them somehow or multiply stuff. Leave them. That's it. Questions? You got 4 problems left. We're not doing all 4. We're only going to do 2 of them. and these bottom two combine everything you've done. So, 7. We start by multiplying. So I start by distributing. I take this and I distribute to those two things. What does that look like? I never expect you to actually write down the line that I'm about to write down. It is just 2 square roots of 5 times the square root of 6 plus 2 square roots of 5 times 2. So again, I don't expect to see that line. What I would expect to see is the line below, which is where you actually just multiply them out. This is going to give me 2 square roots of 30. Now I'm writing 2 square roots of 30 down, but I was thinking, okay, I did not just decide to multiply those together and be done with it. What does 6 break down to? 3 times 2. So if I have a 2, a 3, and a 5 inside a square root, who gets to leave the square root? Nobody. Everybody's stuck. There's no pairings. That's why I just multiplied and I left it like that. I go to the next one. 2 square roots of 5 times 2 is what? 4. Yeah, 4 square roots of 5. Nice. Can I combine those things? No. There's nothing to combine. So I'll put a little box around it. You got any pairs in there? Nope. That's why we went to that. Okay. 8. Last problem of the day. 2 times 3. 6. All right. You got that one. Guess what? That was 25% of the problem. And you got it right. So that's good. We got 6 down. 2 times square root of 5 is, 2 square roots of 5. 2 times the square root of 5. So boom. Square root of 5 times 3 is 3 square roots of 5. It's almost like when we dealt with I. It's kind of like the same idea. So this is going to be plus 3 square roots of 5. The last one, square root of 5 times the square root of 5 is it's 5. Yeah. Square root of 25 is 5. Folks, what we got going on here is just square root of 5 times square root of 5, which is the square root of 5 squared. We had like a whole unit about Shrek and Donkey. Maybe not about them, but they showed up. And we talked about how these are the inverse operations. They cancel each other out. That's what we got going on. So we just get plus 5. Now let's put this whole thing together. What do we think our final answer is? No, but that is a great answer. It's not a bad one. Actually, I've had it in every class today. Not 6 square roots of 5. You multiply them together. So, remember.
Oh, I multiplied.
Yeah, you multiplied. So you just add those two things right there to give us this. And then the 11 comes from the 6 plus 5. Questions?
Why do you stop there?
We stop there because I can't do anything else. It's the same reason as why do you stop here? Same thing. Or why would you stop there? All right. Try to get 2 homework problems done. You can pick the easiest 2, but try to get 2 done. And then that way you at least have a start on this. And then we should be able to be in a perfectly good place when we stamp on Friday. Did I tell
We're
you class we're
stamping?
stamping? Okay.
Why?
Welcome back to geometry.
Okay.
No.
We are stamping Friday.